This lecture we'll talk about components in embedded systems, the hardware components. Specifically, we're going to talk about microcontrollers. We'll start talking about microcontrollers. We'll go on in the next lecture about that too. The microcontroller is the center of the action, so good to start there. That's where we'll be mostly focusing this class, really, is working with the microcontroller. So here's a picture of a board, an Arduino. There are different versions of Arduino boards, but and you have one, or you may have one. This one, this particular board, you can see there's a big chip in there, that black chip over there, and like the bottom part of the board, and that's actually the microcontroller itself. And there are other devices on this board, but the microcontroller is that main chip in there that's going to be executing the programs that we're going to write. So note that the Arduino board, we'll go into great detail about the Arduino board in the next course, but the Arduino board has a lot of other stuff on the board to support the microcontroller, but the microcontroller is that particular chip right there. So a microcontroller is an integrated circuit that executes a program. So this picture of microcontroller looks a little bit different than what we saw before. That's actually the bare silicon. So we're not going to go into depth about how these things are made, but these chips, they're made out of silicon, a semiconductor, mostly silicon. Ours are silicon. And so there's a wafer, a small chip. That's actually what the typical chip looks like. But that's not what you use. It's not in a usable form yet. Before you can actually connect that to anything, you have to actually wire it up. You have to package it, what's called packaging. But that is a microcontroller, and it will be packaged, and then it's going to be integrated into the middle of the system. So the microcontroller, its job is to execute code, and it's the center of the system. So it reads inputs from other components, and it controls other components. Microcontroller versus microprocessor. So that's it's a terminology difference. Basically, the way I think about it, I don't know what the formal definition, but I know how it's commonly thought of. A microcontroller is basically smaller and weaker than a microprocessor. So when you say microprocessor, you're thinking about what you would find in a desktop, laptop, Intel, whatever, AMD, whatever. Big general purpose processor, general purpose or digital signal processor. That's called a microprocessor. Basically, they're more heavy duty. They're very fast, have a lot of memory and all this. A microcontroller is more slimmed down, okay? More like what you would find in an embedded system or an IoT device. Because remember, these devices, they have to be designed efficiently, right? We don't want overkill. We don't want to over-design the system. We don't want to buy the highest end processor, quad core, 4 gigahertz, whatever the highest end is at the time. We don't want to buy that if we don't need it, right? For the tasks that we're performing, maybe we're interacting with users, and these users are only so fast, so maybe you don't need a fast processor. So you want the cheapest processor that will do the job. So you will go for a microcontroller which is slower and cheaper than whatever the high-end microprocessor is. So a microcontroller is generally, think of it as a lower-end microprocessor. Roughly, that's what it is. So it's slower. Typical, by the way, these speed numbers are they change over time, but common ratio. So a microcontroller might be 16 megahertz. That's a slow one. You can go slower than that, 8 megahertz, something like that, 4. All the way up to, I have 500 megahertz. 500 megahertz is sort of a high end. Actually, though, if you look at, say, a Raspberry Pi, that's going 1 gigahertz, I think, so it's twice that. So it's a shifting scale, this range, okay? But generally, microcontrollers are going to be slower than microprocessors and going to have less memory, less of everything, roughly. Less memory, fewer features. So there are lots of other features, and we'll talk more detail about these in the next course. Specifically, we'll talk about Arduinos and Raspberry Pis and the processors, the microcontrollers that are on those devices. We'll talk in detail about what features they have, but they are less than the features that you find in your standard microprocessor for a desktop, laptop. So this picture, this shows a microprocessor after the silicon has been packaged. So that you see it's a black rectangle, black square in this case, right? That black is all packaging. And that packaging is basically to keep the chip safe. Also, it cools it, so it helps propagate heat out because these things get very hot. Also, you'll notice around the perimeter of the chip, of the circuit, there are these pins. They're called pins. These little pieces of metal, essentially, that are used to wire it to the rest of the components in the system. So if you look at that picture, it's a printed circuit board. a little piece of one. Actually, this is the back side of one, so we can't see all the parts on it. But there are lots of other parts that this microcontroller, or microprocessor, is wired to through the printed circuit board. We're not going to actually build printed circuit boards in this class because that costs money we're not going to spend. We're going to do this type of thing, this wiring, manually. But in a printed circuit board, there are what are called traces, little pieces of metal that are drawn onto the printed circuit board, connecting different components. So the microcontroller is at the heart of the system. It's connected to lots of different components that are in the embedded system, in the IoT device, and it takes inputs from them and it sends control data out to them. Now, microcontroller needs to be programmed. It needs to run code. That's what it does. It executes code. So you need to write the program in some language. Now, there are many languages that you can write programs in. We will be using, well, when it comes to Arduino, we'll eventually be using C, C++. And then when it comes to Raspberry Pi, we'll be using Python. But you can use different languages. But at some point, you have to write a program in a language. And then that program has to be compiled or interpreted, and we'll talk about that in another lecture. And the result, though, has to get transmitted onto the memory of that microcontroller. So it has to be placed in the memory of the microcontroller. So inside that microcontroller, there's always some flash memory. Flash memory is just a non-volatile memory, memory that stays after you power it off. So there's some memory, and that memory has to hold the program, so that when it gets power, it starts executing the program from the start. And we'll be doing that in the course of this course and the next course and all the rest of the courses. So the microcontroller has to be programmed. So this term programming, in terms of a microcontroller, means when you write the code. So first you'll write your program on some host platform, a laptop, desktop, which is not the program that you're going to execute, not the chip that you're going to execute it on, not that microcontroller. You typically write the program on a different host processor, like your laptop, desktop. So you write the program there. Then you process the program, compile or interpret the program, or compile it and then interpretation will happen later, but you compile the program. Then that final version of the compiled program has to get transferred to the microcontroller. Usually it's done through a piece of hardware, an external piece of hardware. So here we see in the middle, there's a little board. That board is connected by USB to the laptop, and the microcontroller chip on the side of the diagram, that is plugged into the board. So there's a slot that fits the microcontroller. You plug it into the board, then on the laptop, you would hit program, there's a button that hits program. You program it and it'll write the data into the memory of that microcontroller. So that's one way to do it. Now that is not exactly how we're going to do it, because we're using an Arduino and Raspberry Pi. We'll show that later. Basically, the way an Arduino and Raspberry Pi work is that a lot of this programming hardware that you see in there, that is built into the Arduino board and to the Raspberry Pi board. So we don't need a separate device to program the microcontroller. That logic is basically built right into the board. So we just take our Arduino Raspberry Pi, plug it in by USB into the laptop desktop, and we can program it directly.